Hey everyone, and welcome back to The Explainer. I'm really thrilled you're here today because we're jumping straight into the absolute powerhouse of industrial automation. If you've ever looked at a modern factory, just a highly automated facility, and wondered how on earth it runs so seamlessly, well, you're in the right place. Today we're unpacking the complete guide to HMI projects, and we're basing this all on some fantastic expert insights from Devi Automation Solutions. So I want you to picture something for a second. Imagine a massive, loud industrial facility. You've got conveyor belts moving, motors humming, literally hundreds of processes happening all at once. Now, picture a single operator standing in front of a digital screen. They tap one brightly colored button, and instantly, a huge pump all the way across the facility roars to life. I mean, it kind of feels like magic, right? Well, today, we're going to totally demystify that magic. Okay, let's dive right into our roadmap. We're covering 5 key areas. 1, demystifying HMI. 2, the anatomy of an HMI. 3, how these systems actually work. 4, HMI in the real world. And finally, 5, best practices. All right, Section 1, demystifying HMI, from magic to machine. So, what exactly are we looking at when we see a factory control screen? Well, HMI stands for Human-Machine Interface. At its core, an HMI project is just a graphical application developed to monitor, control, and visualize industrial processes. Think of it as the ultimate communication bridge. You've got the human operator on one side and the programmable logic controllers, the PLCs, on the other. The HMI basically takes all that complex raw machine data and translates it into an easy-to-use touchscreen interface, which allows for, real-time interaction. Let's actually ground this with a really relatable example. Think about an automatic water tank system. On the screen, the operator sees a digital drawing of the tank's water level, the pump status, and a start and stop button. When they hit that digital start button, the HMI instantly fires a command to the PLC. The PLC then physically kicks on the pump, and as the tank fills up, the HMI updates the water level on the screen right there in real time. It's totally seamless, instant communication. Okay, moving on to Section 2, anatomy of an HMI, the hardware and software. Now that we know what it does, it's time to kind of pop the hood, right? An HMI isn't just some isolated screen floating in a void. It's a fully connected ecosystem. Obviously, you have the HMI touch panel itself, but that relies heavily on the PLC controller. Then you introduce the physical world elements, sensors detecting conditions, motors, solenoid valves, indicator lamps. Tying that whole shebang together are the communication cables like Ethernet or RS-485, a solid power supply, and of course, the programming software for both the HMI and the PLC. Every single piece has to work in perfect harmony. But the software side is just as robust. An HMI acts like a digital multi-tool for the operator. A truly professional project isn't just one static screen. We're talking a process overview, motor control, alarm management, trend tracking for all that historical data, recipe management, and even a user login screen for security. Each screen is laser-focused on improving usability and giving the operator exactly what they need at that precise moment. Which brings us to Section 3, how HMI systems actually work, the continuous loop. We've got our components, so let's shift into the mechanics. The biggest mental shift here is understanding that this isn't just a one-way street, it's a rapid-fire, continuous conversation. It works in 5 main steps. First, sensors detect process conditions and blast those signals over to the PLC. Second, the PLC takes those signals and updates its internal memory. Third, the HMI is constantly reading those memory values and updating the screen so the operator sees the live data. Fourth, the operator makes a call and sends a command right through the touchscreen. And fifth, the PLC gets that command and physically controls the devices. This loop just happens over and over and over, continuously in real time. Up next, Section 4, HMI in the real world, packaging and production. Let's take all this theory and put it into practice. Seeing this continuous loop in action really highlights why this tech saves so much time, money, and quite frankly, stress on the factory floor. Imagine a high-speed packaging machine. The stakes are huge here. Any downtime burns cash. With an HMI, the operator sees the conveyor speed, product count, motor status, all of it in one spot. And here's the real game changer. If a fault happens, the HMI flashes an alarm immediately. The operator can pinpoint the exact issue, respond fast, and get production running again. Without it, you're physically inspecting the entire line, wasting incredibly valuable time. The HMI is absolutely your first line of defense. Now let's zoom out a bit. The versatility of these systems is actually insane. You'll find them literally everywhere. Obviously, they're huge in manufacturing, packaging, food and beverage, and pharma. But they also run water treatment plants, power grids, and oil and gas facilities. You'll even see them driving smart agriculture, home automation, and monitoring solar energy. From textile mills to smart farms, the applications are practically endless. All right, our final section. Section 5, Best Practices for HMI Design, Building Better Interfaces. So if you're the developer or engineer building these interfaces, how do you actually do it right? The logic here is simple but crucial. A great interface prioritizes clarity to completely minimize human error. You want a super clean, simple layout using standard color conventions, like red for stop, green for running. Do not overcomplicate it. Display only the essential information so you aren't overwhelming the operator. Alarm messages need to be crystal clear. Keep those important settings locked down with a secure user login. And on the back end, always test your comms with the PLC before deploying, and seriously, do regular backups of your project. It's all about making the operator's job safer and way more efficient. Everything we've been breaking down today actually comes from the expert insights at Devi Automation Solutions. And their logo is honestly a perfect map of the diverse fields we just ran through. You've got the gear and circuitry for traditional industrial automation, the robotic arm for modern manufacturing, a leaf nodding to smart agriculture, and the cloud and microchips symbolizing AI and the industrial Internet of Things. They're really doing incredible work across all these vital sectors. To wrap up our explainer today, I want to leave you with this core takeaway from the source material. Learning HMI project development is an important step toward becoming a skilled automation engineer. Look, these systems are the absolute heartbeat of modern industrial productivity. They boost safety, efficiency, and reliability worldwide. Mastering them? That is a massive career advantage for sure. So after peering behind the curtain and seeing how this magic actually works on the factory floor, I have one final question for you. Are you ready to build smarter automation systems? Thank you so much for joining me for this explainer. Keep learning, keep exploring, and I'll catch you next time.